So, good morning, and welcome all to the second talk of this day. And I'm happy to present Laurent Ploix. Laurent has worked in the development, productivity, efficiency domain for over 15 years, contributing to both FinTech and music industries. During his time at Spotify, he was a product manager for the CI environment and in a more recent role leading the platform insights team. His mission included to understand team and company productivity in a constantly evolving and rapidly growing Spotify. To this end, he applied engineering, user research, and data science to identify necessary changes. In his actual position as a product manager for DPE at Gradle, he continues to make teams more productive through turning data into metrics and then into knowledge and actions. Some people from TNG already had the opportunity to learn in a great workshop on Wednesday about how metrics can help teams to find levers to focus on their goals. Thank you again for that. Today, Laurent will present a mental model that enables the different functions of a company to align and improve value creation. We may look forward to concrete examples, hear about common concerns, challenges, and controversial issues that companies face when becoming metrics informed. I already heard that he sees himself as a developer grown into a data scientist, and I suppose after today's talk, you will have inspired some people to follow this path. So we are very looking forward to hear about your experiences, especially in such a controversial topic as productivity measurement in software development.
Hi, everyone. Ooh, that's strong. I'm very glad to be here today. I want to thank TNG for inviting me, of course. And I will present metrics-informed development, theory and practice. I love to talk about productivity because everyone seems to have a very strong opinion on the topic. And I have too, so that's good. But first, a few words about myself. That's going to be short. I actually started my career on the bottom, like here, like in the financial trading industry. For a long time, I worked with banks and so on. And then actually went to Sweden. And after a few years, I joined Spotify, as you said, and where I was in charge of the CI environment when it was growing really, really fast. And I work on Gradle, with Gradle on developer productivity engineering, obviously. So I've been passionate about productivity for a very long time, before it was called DPE. And because it involves humans, messy humans, technology, processes, organization, and so on. So it's a lot of different topics. So, but how did it start? I'd like to tell you a story. So a few years ago, I was product manager for the CI environment at Spotify. So we had a few thousand developers on the platform, growing by 40% every quarter, approximately, at this time. So it was really, really fast. And so we wanted to be data informed. We wanted to inform our decisions, but we wanted to be able to show progress and so on. So what did I do? Well, I went to my management, and I said, OK, what kind of metrics do you want to see? And what they wanted to see is impact metrics, stuff about the business, how much value can we create for customers, right? And they wanted to understand productivity with a fluffy number. Then I went to the users of the platform, and what they wanted is to be satisfied with the metric. They wanted the CI to be easy to use. They wanted to be able to understand the failures. And then I went to the team in charge of the CI environment. And what it wanted to know is what to work on. They wanted actionable metrics, stuff that they know they could move. To be honest, for a very long time, for actually a couple of years, we struggled with that. Because if you look at the different profiles in a company, we're just not looking at the same metrics at all. And there's always a very big controversy, like what should you focus on? So we wanted metrics that would satisfy everyone and just couldn't find one. So we realized, but wait a second, I'm going to present that now. So we will take a step back today and reflect a little bit. What is a good mental framework to think about metrics and insights? Can we align the different functions of the company? Do we have use cases? And then I'm going to share use cases and show you how we put that in practice. And of course, there will be threats to validity, and everything I'm going to say is subject to risks, obviously. So first, mental frameworks to think about DPE metrics and insights. I'm going to go through that because it's sort of a common language we all need to agree on if we want to talk about productivity in an efficient way. Let's start with a simple thing. If you think about a metric, if you think about something you measure, it usually falls into one of these buckets. Either you're measuring how much work people put on something, how many hours, how many meetings they attend, or something like that. And that's kind of an effort kind. Or you will have the output of that. Hello. Yeah, number of pull requests they make, maybe the number of lines of code they create, the builds in a CI environment, and so on and so forth. Then this has, hopefully, an outcome. Outcome will be the features you deliver to your customers, the developer satisfaction, the lead time, the time to repair incidents, things like that. And then hopefully, if you do things right, that's going to have an impact on the bottom line, on the customer satisfaction, on different types of success metrics you can put on the business. Make sense so far? What truly matters, and we should all agree on that, for a company, the only ones that truly matters at the end of the day are there. All right? We can agree on that. But it's much easier to measure or to talk with someone about the one on the left. Right? And that's actually one of the main reasons it's so hard to align people, is that we just don't look at the same ones. So I would like to take one step back and actually look at a slightly bigger picture of that. All right. Dependency graph. I'm going to take a very concrete example. Let's say that what you want to move as a business is the app rating. You just want people to be more satisfied with your app. And what are you doing for that? Well, maybe one of the things you can do is to iterate faster on features so that you can adapt to the market and, like just adapt, do something better. But how can you do that? Well, maybe you need to be able to iterate faster on the code itself, right? Maybe more pull requests, more like, if you're not able to iterate on the code, that's going to be hard to iterate on features. And maybe what you need to do there for that is to have a faster build time. You see where I'm going with that? There's some kind of line of dependency, of influence of those metrics. But of course, it's a little bit more complex than that. There will be other things that influence iteration on code, maybe the test flakiness. I know you never encounter such things, but I did. Well, but there are other aspects, right? I mean, build time and test flakiness, that's also going to influence developer satisfaction. So it's not like a single line. And of course, that can influence attrition rate and recruitment costs. What I'm trying to get at here is that it's actually a pretty complex graph. You have a lot of those things, right? It can be much bigger than that. And the one on the left, I mean, it's much longer than that, but you get the point. The one on the left are more like effort kind of output kind. The one on the right are more outcome / impact kind, right? So the interesting thing about that is that the one on the left are more what we call leading metrics, and the one on the right are more what we call lagging metrics. What do we mean by that? So the one on the right here, lagging metrics, they tend, as I said, to be like more outcome, impact kind. What does that mean? So in particular, that means they are more stable. There's a lot of less noise. So hopefully, if you change something in your code, that's not going to change dramatically the bottom line of your company for the next 2 weeks, right? There will be exceptions to that, but don't go there. Third thing is, it's quite good for such metrics to help planning over like 1 or 2 years, right? Maybe the thing you want to focus on is recruitment cost, or maybe that's, again, app rating or some other thing of that sort. And that's something you can plan for 1 year or 2 years. It's also a problem because they tend to be delayed. If you make an action now, that's going to take a while before there will be some impact. On the left, on the other hand, it's more like effort / output kind of metrics. They tend to be more actionable. As I mentioned before, there is no code for developer satisfaction or actually user satisfaction, but there is code for build time, right? You can look into this one. And they also tend to be noisy. If you look at the number of pull requests per day or per week or whatever, that's going to go up and down by 20% easily from one day to the next or weeks to the next. Which means that it's a lot harder to understand if you make an impact, right? Because it's just statistics. You can use them for tactical planning. If you want to change something in the next, say, 15 days or even 2 to 3 months, that's something you can look into. And of course, they tend to be gameable. Well, we know what that means. Like if you put pressure on people and say, like, please move that metric, well, they will. But the value with that, you know. And last thing is vanity metric. So it's pretty easy to look at a metric that looks really good and feel proud about it, but it doesn't really mean it creates value at the end of the day. Like, again, when I was a PM of CI at Spotify, we had some systems that could build the same software 40,000 times a day. Yeah, but I mean, that feels good, but does that even mean that creates some value? You don't know that, right? Anyway, that's, you see the point. So, maybe the key thing to understand here is that no metric, none of them, is going to make sense to everyone at the same time. Deal with it, all right? So what I mean is that if you're trying to look for the one metric that's going to make sense for everyone, simply forget about it. It's just not going to work. Some of them are better, some of them are worse, but none of them is going to make sense both to the CFO and to developers and to product managers at the same time. Okay. We can remember that the things that matters at the end of the day are the one on the right, and we look through some examples. So again, metrics which are both value-focused and actionable probably don't exist. So what can we do then, right? So what we do have in common is the graph. That is something we have in common in a company. And that's actually important. What you can do is align the different functions in your company that, yes, we collectively believe that if we make it faster to iterate on the code, we're actually going to be able to iterate on feature faster. And maybe that's going to help us with the app rating or something else. The important bit is that the metrics themselves are not the important part. What is important is to align the different parts of the company that, yes, we have this belief about this graph of dependencies. Make sense? Important thing is that it is theoretically possible to actually measure the actual impact on this one. And I say theoretically possible because you typically need to use A/B testing internally on your own developers. I've done that. It's fun. But you need to have enough developers in order to do that. And if you don't want to run, otherwise, I mean, if you don't have enough developers, then you're going to have to run your experiment for 3 months, and that's not going to be okay. So you can also use other techniques for causality inference. But frankly speaking, what happens is that in small companies, you typically don't have this luxury of running A/B tests against your own developers to see this inference. So you use your best judgment, I would say, and you also use research. There's tons of papers mostly from Google, LinkedIn, Microsoft, that actually have identified a number of these relationships. I would say use them. They're pretty good. So we've seen activity to impact metrics, or effort to impact metrics. We've seen the graph of dependency, and I would like to introduce you with a second framework to reason about those things. The pyramid. Okay, what do we mean by that? At the bottom, you can collect data in your own company from tickets, from code, from test results, from the meetings, from documents that people create, from anything you can think of. Data does not have an opinion, it's just data. You typically extract it in a raw manner, and then you apply some transformation to make it into a database that you can query easily. It's at the base of the pyramid, and it needs to be of good quality, obviously. Then on top of that, Because you got data, you can create what I call information layer with metrics that you can compute, and all the means that you have typically dashboards or other ways to kind of make sure these metrics can be looked at. Examples would be mean time to repair an incident, lead time, so the time from an idea to when you deploy, developer satisfaction, which is a survey, but that's also data, a metric you can collect. Information can have an opinion a little bit. I mean, metrics can be good or bad, depending on which direction they go, but not really. The third layer is probably the most important. It's what interpretation you have of that, how you make sense of that information, and how do you infer causality, for instance, between two metrics. So, and this has opinions, meaning, see what I mean? So we strongly believe that, for instance, if we have a longer build time, that will cost us a lot in recruitment costs because people will leave the company when the builds are too long. That's an insight, that's not a metric. Make sense? An insight that's actually been pretty powerful these recent years is the DORA metrics. You might have heard about those DORA metrics. I'm going to look into that. The 4 main DORA metrics have been proven to be quite predictive of company success. That's an insight. Right. One thing absolutely key here is that even if you start collecting a lot of data now, even if you start computing your metrics, and from that infer some insight, you will make mistakes. There will be bugs in your data. There will be issues in how you compute your metrics. Deal with it, okay? So there will be times when people come back to you and say, like, I don't actually believe what you're telling me. Like, this is not correct. Like, we need to recompute those things in a different way. And that means that data has bugs, metrics have bugs. You will need to iterate, you will need to evolve them. You will need to measure engagement, make sure that people actually look into those metrics. I mean, it's really no use creating metrics, nice dashboards, and then nobody looks at them. Okay, so it is really important that engagement with what you're doing is actually good. So, does that ring a bell, what I just said? I said, you need to start somewhere, you need to evolve, you need to accept there will be bugs, you need to iterate. And you have customers, you have stakeholders, and so on. It's sort of a definition of a product. You got a product, everything you do has customers, bugs, you need to iterate on that, and you need to evolve. So the metrics are products as well. Make sense? Right, so with that, that's a wrap-up for the frameworks that I use. Effort, output, outcome, impact, oriented graph of metrics is the company alignment, data information knowledge, and of course the fact that metrics are product and you need to iterate on them. With that, I would like to go into a few use cases and lessons learned and a few burns. I will look into surveys, what can we do about that from there. There will be a lot of insights you can get from survey, a lot more than you think. I will look into DORA metrics in a slightly different way than we usually do. And I will, we will look a little bit into technical depth and what we can, like how or if we can measure that or at least predict it a little bit. And the insights and metrics and how to plan work inside a company. So let's go. All right. A lot of the major companies, the ones that are most efficient when it comes to developer productivity, tend to survey their developers, typically on a quarterly basis, with questions about how do you feel about your own productivity, how do you feel about the team productivity, how autonomous are you with your decisions, if you get clear product directions, and so on and so forth. So there's a lot of topics about a lot of different aspects, but most importantly, I would say, you got metrics about perception of productivity and, for instance, like the ease of use of different tools they have in a company. So what can we do about that? I would like to mention that Google has produced a lot of papers recently that explain that very well, so you can go read them. This is important to realize that the metrics I was just mentioning, the ones you capture by just asking people, they are not in the same place in the graph I was mentioning before. Remember the graph? Actually, they're not exactly at the same place. And you can think maybe there are some aspect of influence. So the question would be, can we try to see if we can see if there's an impact from effectiveness of CI, for instance, and personal productivity? Is there a way we could look into that, or at least have some hints? So here's what we can do with that. So I would like to go back on this one and say, what we're looking here is survey data is here. What I'm going to show here is trends and correlation between the different metrics we capture with surveys. And the causality aspect will typically require more user research afterwards. But let's go into that. Here's a very concrete example of what you can do with such things. Bear with me. You got questions about, for instance, how do you feel about your own productivity? And another question is, how do you feel about the use of this tool? GitHub Actions, Jira, you name it, things. Okay. What you can do is put them in this graph here, or this chart. On the x-axis, the number of people who are negatively impacted by, say, Jira or GitHub Actions or anything else. I don't know. On the other axis, the correlation with the self-evaluated productivity. The red one here are the tools where people complain a lot about it. A lot of people rather complain a lot about it, and it's extremely correlated with their self-perception of productivity. Wait a second, right? Also, if you do that on a quarterly basis, you can see these points move. And maybe that's going this direction or that direction, I don't know. See what I mean? So now, important to realize this is a correlation aspect, and correlation and causality, not exactly the same thing. So you basically get to the second level, the information level, but not to the insights level just yet. But what you can do then is user research, go interview people, right? And try to understand if there is indeed an aspect of causality behind that. Make sense? This is an extremely powerful way to know where you can add resources, because maybe the tool is doesn't have enough people to support it or to evolve it, or to actually kill it if it doesn't do a good job. Note that I took an example with both, both the satisfaction on the tools and the satisfaction with self-productivity both come from the survey. But you can see that you can also do that with what we call hard data from systems. You could see, is there a correlation between how people feel about their productivity and the build time they have? And you can do the similar thing. Second topic, I'm going to look into what I call local DORA metrics. Okay, show of hands, how many persons know what the DORA metric is? Okay, I'm going to explain. All right, here's a look. Okay, there is a very interesting piece of research and a book called Accelerate that has been published by Nicole Forsgren, mostly, that show that there is let's say, a certain level of predictability between having decent DORA metrics and a successful company. I think that's very short. And what are they? MTTR, the time it takes to recover from an incident. That's the first metric, the medium or mean time to recover from an incident. When you deploy something in production, what is the percentage of times when it actually fails somehow? When you create an incident, you deploy and then it doesn't work. Third one is from ID to production, from the time when you start working on something and when you actually deploy it, how long does that take? Are you talking weeks or are you talking years? Deployment frequency, are you deploying every second minute? Are you deploying every second day? Are you deploying every second, I don't know, months, etc., etc. And then the fifth one actually came. Usually those ones are the most common, but they have added reliability. which is typically what is the percentage of time that you have your system is up and running. Does that make sense? And what you can see here is those metrics, they are kind of far to the right, more like close to business value, not quite business value, but close. And they are predictive of success for a company, but they are kind of hard they're not really actionable. If I go to a developer and say, could you please improve lead time? Like, where's the code? All right? It's difficult. But we know that's true. So getting back to what I said, this is something more like to the right, and we'll need to find the leading metrics that can have an influence on this one. Okay? So this is what I said, like this, we know there's some level of predictability of that. Like, so before I go into metrics which makes more sense to the developers themselves, I would like to take one step back and describe in a very simple way the average, let's say, the typical way a developer works. All right, so you got the main branch or the master branch if you use Git, but if you use something else, it's not super different, okay, where all the code goes at the end of the day that is supposed to be in good shape. Here you got two developers in the example I have. What typically happens is that a developer takes a certain version of the code locally on their own machine, and they start doing work on them. And guess what happens? Like usually what happens is that I'm a developer, I want to make a change, so I make a step in the right direction, and then of course I break something, right? I break the build, I break some test or something. And that's going to take me a few iterations to get back to the green level when it works. And then I take another step, and that happens again. Okay, that's typically what happens. I would say, by the way, that's completely normal. Developers who always have green builds, I don't know. Someone here? Okay, probably not. So the time it takes here is one of the most important thing for the productivity of a developer. The time it takes between you take the step in the right direction and then you go fix it. That's basically this iteration here is extremely predictive of development productivity. If that takes you 2 hours to iterate on any change you make, or if it takes 2 minutes, you can see the big difference that makes, right? And there have been cases where if it takes 3 hours to iterate, then you can make 2 changes a day. That's like a horrible situation. The second thing that happens, okay, yeah, so I was like, the time it takes here has to do with how long it takes to get the issue, like to be reported the issue to the developer, how long does it take to investigate problems, maybe there will be queues in the system, and of course the build time has a big effect, but that's only one of the factors, by the way. The biggest one actually is how long does that take you to understand the problem. That's actually the main one most of the time. So how clear are the error messages you get, stack trace, and, or whatever that is. And I've been in a situation where the stuff that people got when it failed, either locally or in CI, would be like 20 megabytes of log files. Good luck. So, of course, that doesn't help. So, the second thing I'd like to mention, okay, once you're done and you're happy with your change, then you merge it back to master. And of course, in parallel, there will be other people doing the same thing on other parts of the code. And here, this guy here, I did for like, I mean, it took him some time, and the other person, it happened twice. This is what I personally call the local time to repair, right? The local MTTR. That's like either with you as a person on your company, on your laptop, or in the CI environment, or possibly on master. Because of course we all know that when you push code as green, everything is going to be green here, right? Okay, no? Okay. We all know that's never supposed to happen, but it does. Right? So many reasons for that, and we could go into a lot of details, but that's typically what happens. So this is the closest you can get to an incident, I would say, from a development environment. Because once this is red here, nobody can branch out and nobody can merge. So you effectively kind of stop the company, potentially. Okay. All right, so wrapping up that thing here, what I call a local error metric is local on your own computer. How long does that take you to recover from rain to grid? The same thing in a pull request context or an equivalent. The same thing on main. And then you're going to have an equivalent here where the number of times that you break master would be an equivalent of failed deployments. The number of times that, like the duration of pull requests would be an equivalent of lead time. The merge frequency to main, how many times you have pull requests that get merged, would be an equivalent of deployment frequency. And the build flakiness would be an equivalent of reliability. And those metrics are actually very actionable for developers. All right, so now let's look into tickets. I love tickets. You know, GitHub issues, Jira tickets, etc., etc. If you want to know if your team is going in the right or wrong direction, that's actually a pretty powerful thing. So let me give you a very simplified example, but those numbers are actually true numbers coming from a true project, like a real project. Here on the top, I've just counted the number of critical bugs that we worked on for a while. And at the bottom, the tickets are done that are not bugs, basically, stuff that you want to do to improve, right? So no incident, no bugs. That's what we call value-adding tickets. All the rest is about fixing shit. And what you see here at the beginning is that the value-adding tickets grew slowly, whereas the number of critical bugs went really fast. So just by looking at that, you can see that this team has a problem, and probably some technical debt problem. Probably, not necessarily so, but that's be one thing. And here, it became critical. The percentage of time we spent on fixing critical problems became way too high. So we had a big initiative to, well, enable like more test coverage, fix technical debt issues, and so on. But it did take a long time. I mean, this is a month, so you're talking about a year, a long effort, where in order to lower the number of critical bugs, it takes a long time, while at the same time you can see this growing. And this is, in some way, a very good way to measure the sort of productivity of your team, if you want, because what actually matters at the end of the day is only those ones. The rest is only something slowing you down. All right, so the best advice I can give you is that if you want to understand how healthy, technically speaking, a team is, just look at how many tickets they take in order to fix problems, and how many do they take to actually improve the situation from a feature point of view. Very simple. All right, so technical debt. I love this one. I love this one. Technical debt. How do you measure that? Can you? The technical debt is typically something that is extremely hard to measure. When you see it, you understand what it is. Yeah, like when you see it, you know what it is, you know it's there. Let me give you a real example. This is in the context of a project where you released in that's on-prem software. So you make a version and you send it to customers and install it locally. And then, of course, if they have bugs, they report them and you need to make a hotfix. Okay, make sense? Every color is a version of it. So here goes the story. We start working on version 1. And we arrive here, and everybody says, you should not really release, it's not ready. But someone says, yeah, we do release. Right? Because we can. And now we start working on version 2. But see what happens here? You continue working on version 1. Why is it? Because, well, we got hotfixes. Like people come back and say, hey, you got a real big bug here. You need to fix it. It's not OK. So what happens here is that the version 2 here only has like 2/3 of the company working on it. The rest of the company effectively is fixing problems from the previous version. And guess what happens here? Now, OK, we release version 2. Version 3 starts. And, well, what you see here is that it's not half, but it's even lower number of people working on the next version. Okay, so, and you think, like, if it continues like this, that's going to be a catastrophe. Because at some point, we will not be able to create any sort of new value we're only going to be impeded by the previous stuff and go make hot fixes instead. So what we decided to do here is say, you know what, the red version here, the 4, it's only bug fixes. No new things, nothing, just hot fix, just fixing problems. And that actually lasts longer, if you see. Like this one was 3 months, and this was more like 6. And here comes the next version. And the next version was a lot less impeded by the previous ones. Okay, like the hot fixes we had to do for the orange version were, say maybe 10%, but no more. Okay, so what I'm trying to show you here is that maybe you cannot measure technical debt, but you can see it. So just by looking at, in this case, that's actually the time we spent in CI on different versions, which is a proxy for the effort we put in that code. Does that make sense? But again, you cannot, if you have this type of graph, you can show to your manager and say, here's what happens in the past. Do you want to redo it again? Your choice. But that's actually a good way to measure or actually to visualize technical debt. Something we can, like I'm going to go a little bit further with that, really fast. How many minutes next? 5? Okay. One thing you can do about technical debt is you cannot really parse a file and say, yeah, just by parsing the file and doing something, I'm going to tell you if there's technical debt here. But one thing you can do is you can take a number of files from your code base, like a few hundred maybe, and then you ask people to evaluate them. Okay, is that like super good or is that super bad? And then at the same time, you can also collect objective facts about this file. How old is it? How big is it? And a number of other measures. And then you can make a regression. And then what you can do is realize that maybe some factors are more predictive of technical debt than some others. And by applying that to the entire code base, you have something which is completely imperfect, but will give you a very good hint as to where to look at to fix technical debt in your code. That's a very efficient way to look into it. Note that if you realize, for instance, that the age of the file, just like since creation, is a good predictor, that actually means that you are probably not very good at updating or keeping it up to date. You can interpret that this way. With that, a very fast review on how you can use insights and metrics to plan work. And I'm talking about OKRs, or similar thing. It doesn't really matter if that's an OKR or not, but you get the point. On the right here, you want people to focus on the lagging metric and have more like strategic planning for, say, 6 months or a year, because those things are going to be slow to move. But then once your management has decided that the most important is to focus, say, on the app rating or maybe recruitment cost or some other things, then the idea is that collectively, as a company, you can agree that as a department level, what you will focus on is this thing. And then when you go down at the team level, where the iteration is maybe shorter, you can go back to the left and say, I'm actually working on build time now as a developer, as a team, because I know that it will have this impact in this direction. Right. With that, very, very fast. Something really important about risks and problem with that. I'd like to mention that every metric will be gamed if you go to people and say, by the way, you're going to be evaluated based on that metric. Every single one of them. The other thing is that every metric has shortcomings, every one of them. Live with it. It's just what it is. And you're not here to... Actually, metrics are here to inform you, not the other way around, right? As soon as you try to push pressure on people for metrics, what happens is that they will game them and the metrics will be meaningless. So don't do that. And another thing is that you want people to come with hypothesis. My hypothesis is that by doing this, I will influence that, but not with strong opinions, because strong opinions will lead to conflict. And hypothesis is just an hypothesis. Maybe it's right, maybe it's wrong. It's fine. And the second thing, that's the last slide, is you should not confuse the map and the territory. You know what it is? Like map is metrics, like to give you a certain visualization of your company, but this is not your company, right? It's just part of it. It's just some aspect of it. There will always be tension in a company with how you define metric. Again, live with it. You have a product manager for that because they are products, and you can deal with it. You should not discard people's perception, and like surveying is one of the best possible way you can go for to actually capture a metric. For instance, even the DORA metrics, you want like how often do you deploy? Well, if you don't have data for that, because it's typically difficult to have it, just ask people. And you know what? They will tell you the truth most of the time. And last thing is that the company is a system of teams, and if you, for instance, push too hard on one given team to, for instance, optimize for deployment frequency, what will happen is that this team will stop collaborating with the others because they will only focus on their own code. So be very careful when you go to a team to not think just in terms of metrics, but mostly to think in terms of impact that they want to have, and that the metric is just one of the ways you have to evaluate if that's successful or not. With that, I would like to thank you. I hope that's useful.
Thank you very much for the talk, and due to the nearly perfect timing, we have some minutes for questions. So are there any?
Thank you very much. We are, of course, seeing similar topics to try to get under management. Now, with the size of Spotify and the graph dependency kind of approach, do you go into quantifying those dependencies? Did you make an effort to really go further into the graph, which, given the nature of how you, what platform kind of thinking you are in, might be a natural way to go?
For some of them, yes. You commit some, you can, just looking at a number in the past, if you have like 3 years of data, you can actually see, say, correlate those metrics and measure the correlation, yes. Mm-hmm.
And if I may just add a second, then once you are in this graph thing, I mean, it's so nice. Of course, the graph is always, with all its degrees of freedom, still a simplification of things.
Yeah, it is.
But you would love to see more included and eventually extended to include the organization somehow in the graph, so to have this to project further. Is there some idea of this?
So you want to have to use this graph, but...
I mean, you have metrics, you have a graph of metrics, you want to use them for a team.
Yes.
Now you could now include team entities in the graph. Would you go this direction?
I don't know.
Okay.
I got to think about it.
Okay.
Yeah.
The space of local DORA metrics is, I think, under the usual governance of the respective development teams. But if you enter now the space of the SPACE metrics, many more parties are involved, which may or may not want to collaborate in order to get the results of such a survey. How do you overcome the cultural differences, for example, if agile coaches, scrum masters, etc. are involved, who do not like or are not informed to create these kind of surveys?
Okay, let me make sure I understood correctly. Your question was about surveys, and if people don't want to see the result of those surveys, or?
They may be frightened by the results which they
don't like.
Or
yes. All right, so that's a tough one, because now we're talking about the culture aspect of a company. The only thing I can tell you about my personal experience is that the team I was leading had complete freedom to publish anything on anything when it comes to the findings of those things, and we did. And that didn't always make people happy about like the result they got, but if you're in a culture where when you get bad news, well, that's actually good news that you know it exists, so you can focus on it. right? Like if suddenly you see that you have a big drop in development satisfaction, you can take it badly and say like that's an insult to me or whatever, or you can take it, well, that's good news that I know that. Now I can go and try to understand why, and then I can fix it. So it's mostly a culture problem. To be honest, if you're in a company where you cannot face the facts, you cannot face the outcome of a survey and so on, then you're in trouble, actually, because you will not be able to get better. And that's all I can say about it. I think it's absolutely crucial that the entire culture, and it comes from the top, by the way, is very happy to get bad news. Because if you get bad news, you know at least, you know they are there. That's the first thing. Like, because otherwise, well, you would not get bad news, but the problem would still be there. Like the worst that can happen is that if the bad news you get is that people resign because they have been pissed off for a full year or 2 years, but you didn't know that. So, does that answer your question?
Yes, thank you.
I don't think the microphone works, does it?
I think now it's working, thank you. I was wondering, so in smaller companies, in a project that I've been working before, we were about 100 developers,
Yeah.
so not even that small, but the Works Council was very concerned that by collecting DORA metrics, you are actually measuring individual developers or could infer that from them. So I'm actually quite interested by these local DORA metrics because it feels like on a team level with the right hypothesis, you could collect team data within the team without it really leaving the team.
Yeah.
My question now, do you think this individual teams measuring individually would be sufficient, or would you still need some DORA metrics on top of the local DORA metric?
So both. Basically, my personal experience that the local DORA metrics are, let's say, predictive of the health of a given team. And that's, let's say, a big factor in productivity. That means that this team can deliver code faster and easier, but note that that's actually not going to tell you if they deliver the right thing, right? That requires more like a product decision. So maybe that's not exactly your question, but the second question, the other part of your question is, do you also need the global one? Yes, but they are not at the same place actually in this graph, right? The local one are more to the left, the global one are more to the right. And again, in my experience, there is let's say, an influence or an impact from the local one into the global ones. So yes, you need both. But I would say, when it comes to measuring actual DORA metrics, like the proper ones, if I have a piece of advice to give you, is that to realize it is actually very hard to do it right from data. Like anyone who's tried to implement that properly in any company will realize it's really, really hard to do. Why is that? Because, for instance, time to repair an incident. Well, what is an incident in the first place? Do you have a database where you put incidents? Do people actually update this database, or just starting with that? Or deployment? What is a deployment? Is an A/B test a deployment? Is a blue-green deployment a deployment? Like question mark. Is a feature flag a deployment? I mean, I don't know. That depends how you want to see it. So I would say the best is make your own definition in your own company. But frankly speaking, the best thing you can do is just go ask people. And you will get a decently okay approximation of your DORA metrics in a company. And that's going to be a lot cheaper than to actually implement the full thing.
Okay, regarding the time, perhaps one quick last question, if there is one.
So my question would also be about these local DORA metrics. So if I think about, if I imagine this, I've broke something in my local development, and how long does it take me to fix this? This spans multiple orders of magnitude, right? It might be that I broke something and I know, oh, I've just made a typo here, I'm missing some annotation, or it might be that it takes me 2 days to find out why something seemingly unrelated breaks. Is that an issue in collecting this data, and if yes, how you handle that?
Okay, that would be a long answer. We talked about that on Wednesday, right? Okay, there's a distribution for this TTR. okay? And distribution looks, it's not a normal distribution. How much time do you have? Is there a coffee break? Okay, 1 minute, 2 minutes. Okay, very fast. It looks like this. It goes. There is nothing you can do below the time it takes to build. Okay, so there is absolutely nothing there, and then it goes like up, and then it's super long tail. Okay, so what you're talking about here is a long tail, and the ones things which are on the right, where like people take more than a few hours to go fix things. This is very important to go look into these things because they correspond to high technical debt issues or broken environment or things like that. And if you work on those ones, you're going to make this curve a lot lower and effectively move the median or the mean and make your normal iteration a lot faster. I'm not sure I answered your questions, but I think there's a coffee break and people want coffee.
So
I'm going to be around.
Yeah, thank you. Thank you, Laurent, again.